All right, good morning. Welcome to lesson 1-6. So before we get going on 1-6, I want to review us of what we learned on 1-5. Particularly 1-5 was about transformations. And on lesson 1-5, I had two rules with transformations. So rule number one was what I call HIVO. Now, from those who are listening online, what did HIVO refer to? All right, so HIVO stands for horizontals. Transformations occur on the inside. Horizontal is inside. The V and the O stands for that vertical is outside. So that's the first rule. The second rule we learned about in lesson 1-5 was what? It was that inside lies. According to rule number one, inside is horizontal. Inside lies, outside tells the truth. Outside tells, that S kind of got messed up in there, tells the truth. All right, so that's our two rules that we have. HIVO, which is an acronym, horizontal is inside, vertical is outside. And number two, inside lies, outside tells the truth. So what does that have to do with anything? When I look at number one, I personally see four different transformations. So normally we just have f of x or g of x, something like this. But on this problem, I see that there are numbers and symbols along with the f of x. There are four different transformations. We have this, we have that, and we have a -2 here, and a +4. Now, if something's in the front, you treat the negative different than the 3. Once you get to the inside or the back end, the negatives go with the numbers. So let's just go from left to right. Using my rules here, this negative, is that negative on the inside of this equation, or would you call this the outside of the equation right here? What would you call that, inside or outside? Is it inside or outside? Outside.
Outside?
It's outside, very good. And so according to rule number one, outside is with the V, and that means it's vertical. So this is a vertical something. Vertical, again, means up and down. So this is a vertical, and what we learned in the videos, a negative makes a reflection. This is a vertical reflection. So if it's a vertical reflection, that means that on the y values, each y value would get reflected vertically across the x-axis. So like this point is 0, 3. 0, 3 is this point. It would get reflected down here to 0, -3. The y value gets a negative. Or if it started with a negative, like this one, -3, -6 would reflect over up here. This one would reflect up here and become -3, +6. So what happens with a negative on the outside is your y value changes from positive to negative or negative to positive. They just switch. So that's what would happen there. Now, we're not doing this graph yet. I'm just visually giving you a representation of what would happen. Okay, so that's a vertical reflection, and it's over the x-axis. That doesn't mean the x changes. It just means you cross over the x-axis. So that's the visual what happens. You cross over the x-axis. So this point would cross over the x-axis, this point would cross over the x-axis, this point would cross over the x-axis. That's what happens. So that's why I put over x-axis. Now you have a 3. This 3, is this 3 inside of the f equation, or is it outside of the f equation, this 3 right there? So that 3, I've been told, is outside, and I agree with the student. That 3 is outside. So since it's outside, that means it's vertical. And vertical, by the way, tells the truth, which means this 3 is multiplying. So this, all the vertical y values get multiplied by 3. Said another way, it's called a vertical stretch. And they're going to use the term by factor. That just means you multiply by factor 3. So that's a vertical stretch by factor of 3. You just multiply all y values by 3. So if you were looking at this point and you had to vertically stretch it, what you would do is you would take the y value, which is 3, and you would just say 3 times 3 equals 9. So this point would get shifted up to the value of 9. That's what happens when you have a 3 up front. Okay, now let's look at the next transformation. This next one is the -2. Is this -2 inside or outside of the f equation? So here's f with its parentheses. Is this -2 on the inside or the outside?
Is it on the inside?
It's on the inside. So now I'm here. That I right here stands for inside. If it's inside, it is horizontal. So horizontal is inside, vertical is outside. That's what HIVO means when you hear me say HIVO. So this is on the inside, which means it's horizontal, and the inside lies. So what do I mean? -2 is thought of going left 2. See how that's a -2 right there? We usually think of -2 being left 2 units. But because inside lies, when you graph this, it'll actually shift everything right 2. And it goes right because the inside always lies. That -2 is going to switch it to a +2 this way. So every point would get shifted 2 units over this way. So everything on the graph would get shifted 2 units over. That's how this graph would look with that transformation. It'll shift it over 2 units. And then finally, right here, a +4. Is that +4 on the inside of this parentheses with f, or is it on the outside?
Outside.
So it's on the outside. It's outside of these parentheses. So if it's outside, it's vertical. Vertical is outside. And if it's outside, it tells the truth. So what do I mean by that? I mean +4 goes the way you normally think it. It would shift it up 4. Shift up 4. So if we looked at this graph, what would happen if you put all these together is all the y values would reflect, all the y values would get multiplied by 3, all the points would be shifted right 2 units, and all the y's would then be shifted up 4 units. So that's what would happen to this graph. Now let's take a look at the next one, number 2. It says draw a sketch. I won't. All right, I want everyone to take a few seconds. I'm going to pause the video here, or if you're watching later on, not live, make sure you just pause your video. I want you to think to yourself, what happens with these 2 values? And then I'm going to come on and tell you the answer. All right, I have a student who gave me the correct answer. They said, this is inside, and inside is horizontal, and it lies. So instead of going right 1 on the x-axis, that would be telling the truth, it goes left 1 on the x-axis because inside is horizontal, and horizontal means x-axis. So this means go left 1, specifically shift left 1. So the whole graph would shift left 1, and this is on the outside. Outside is vertical, and vertical tells the truth. That means vertical's y-axis, it would go down 1 unit. So these don't cancel each other out, even though it looks like they might, a +1 and -1, because this is inside, it's horizontal. This is outside, it's vertical, and therefore, since they're separate, you don't cancel them out. They just will shift the graph differently. Now at this time, I'm going to pause these and show you visually how all this would look. So we got our answers for 1 and 2. Let's look at what would happen on the graph. So to do so, I'm going to scoot this over, and I have the Desmos graph right here. This was our original graph. And now I'm going to add some stuff to it. So on the first one, I'm going to say g of x equals -3. Now I'm just going to start with negative f of x. I'm going to start there and just show you. So what did we say that negative does in the very front? It reflects everything over the x-axis. So here's my x-axis. Do you see how this graph is just reflected over the x-axis? How the red and the blue are just reflections of one another? How everything on the negative side of the, like -1 here, became a +1 on the y's. So all the y values shifted. This point right here would be the point 2, +1. So what happened is the y values switched because it was on the outside. Outside's vertical, and the negative means reflect those values. And so any of these values just simply got reflected. This would be 0, -3. What happened is the y's changed from positive to negative. The x's did not, the y's changed. Okay? So now, the 3 in the front, that 3 we said was outside. Outside's vertical, and vertical just means y. If you haven't picked that up, horizontal means the x. So the x's are inside, the y's are outside. This means multiply all your y values by 3. So if I put a 3 here, every y point that you can see right now is going to get multiplied by 3. So I'll put a 3 there. And so this corresponding point, this is truthfully now a -3 multiplying on the outside. So what is 3 times -3? The -3 here times this 3. What is that? What is 3 times -3?
-9.
-9. And look at this point. Look what we have for the y value. You see what happened? This -3 did not change the x, but what it did change was the y. The y went from +3 to a -9. It got multiplied by -3. Or check this point. What's -1 times -3? -1 times -3 is
+3.
+3. As you can see this point, it shows it's +3. So the x values, did the x values change or just the y values?
The y values.
Just the y values. Okay, so now let's check this out. Then we had a -2. Now that -2 is on the inside, which means it goes with the x. But the inside lies. So instead of the x getting smaller by 2, what's going to happen is all the x's are going to get bigger by 2. You're going to add 2 to every single x value. So I'm going to come in here and I'll put the -2. And you'll see what happens is every single x value. So I'm going to take this point and look at it down here. This point. Notice what has happened to the x value from 0 to 2. How do you get from 0 to 2? We added 2. Now, why did we add 2 when it looks like a -2? What's the rule say?
Inside lies.
Inside lies. So instead of subtracting 2, we added 2. So this 0 was added to and became a 2, and the y got multiplied by -3. Or take this point. This point got shifted right up there, and so it became, I'll put the point on the screen, it became the 2, we add 2 to it, so it became 2 plus 2, and the y was -1, and it got multiplied by -3. And so we had this point, let me change it to red so it all blends together. This point here, notice is 4, 3. So it added 2 for the x, the y got multiplied by -3. And now let's take a look at our last transformation. It says add 4 units. Now that +4, is that inside or outside? That +4, is it on the inside or the outside? It's on the outside. And outside is vertical, meaning y values. And outside tells the truth. So that means all the y values are just going to get shifted up 4 units. So any of these points I have are going to get shifted up 4 units. So when I hit +4 on the outside, this point is no longer at -9. It got shifted up to -5. And this point's off the graph because I need to add 4 units to it. So I'm going to come back down here to my point, and I'll put +4, and now it's on the right spot. So how did I get to 4, 7 from this point of 2, -1? Is I multiplied the y's by -3. So the -1 got multiplied by -3, and it became a +3. And then we added 4 to it because that's what the outside said to do. And when you add 4 to that, 3 plus 4 became a 7. And thus we have that point right there, which for some reason, there it is, showing you as 4, 7. So that's how you get all your points. Again, if we wanted to try it with the maximum here, you would first multiply the y by -3. So it became a -9. Then this says shift it right 2 units. So it got shifted to there. Let me do it this way. You would first multiply 0 times the 0 3 times, and will be a -3, which equaled 0, -9. So first we had this point here, right there, of 0, -9. That's what happens after the front transformations. Then it says inside lies, so we added 2 to the x, and so this point got shifted 2 units this way, and it became 2, -9. And then finally on the outside it says add 4. So we would add 4, and that's what shifts it up 4 units, 1, 2, 3, 4, and you get this point right there, which is 2, -5. And so now let me take these off, and let's take a look at number 2. Number 2 just said shift left 1, down 1. And I already have that one graphed right here. Check it out. When I click the +1, that's left 1 because inside lies, and it's an x. Inside's x, horizontal. Outside tells the truth, so it goes down 1. Left 1, down 1. Is that what happened from the blue graph to the red graph? Did it go left down 1, down 1, left 1, down 1, left 1, down 1? You see how that worked? Am I making sense or am I confusing you? All right, now we're going to take a look at what many consider to be harder, but it's just because you kind of forget how the absolute value rules work. So let's talk about absolute value. What absolute value does, these 2 vertical lines here, is they turn any value positive. But here's what's crazy with absolute value. You have to look at, is it on the outside or is it on the inside with the x? So this absolute value, would you say, following these rules, that this absolute value is on the outside or the inside? Is it outside or inside? Those 2 vertical brackets for absolute value are on the outside. So if it's on the outside, what that means, let me write that on there, it's outside. So going off the 2 rules, if it's outside, it's vertical, or meaning it's the y values. And outside tells the truth, which means any negative y becomes a positive y. So we're going to take the absolute value of any y. Now, what does that mean? Let me come over to Desmos to show you this way. To take the absolute value of any y, what that means is if the y is already positive, it stays positive. But if the y is negative, it turns positive. So I'm just going to use these 4 points to help you out. And what we're going to do is we're going to take the absolute value of the y's, because the absolute value symbol is on the outside, which means y. The F represents y. The inside, the x, is your x. So we're talking about the y values here. Okay, what is the absolute value of -6? The absolute value of -6 is what happens to a negative with absolute value?
Into a positive?
Turns into a positive. If you're not sure, I'll just pull up the keyboard and show you. There it is. -6 turns into a +6. That's all that happens. So this point, the x doesn't change. The x will still be -3. It's going to become, this one's going to get shifted to become -3, +6. So I'm going to go -3, +6. That's right there. -3, 6. And I'll erase this so we're not confused. This point right here became that point. Now I'm going to change colors. Now let's look at the absolute value of -1. What is the absolute value of -1?
1.
1. And so this point's going to be shifted right there. And so the x doesn't change, but the y does. It becomes a 1. Now what's the absolute value of +3? The answer is,
+3?
It's still 3. Absolute value it's basically the distance. So it's like it takes away negatives. And distance, you don't ever say if you walk to school, well, I had to walk a negative mile to get to school, but I walk a positive mile to walk home. That's not how distance works. Distance is always positive. That's what absolute value does. It's like taking the distance. So This just point stays the same. So absolute value of a positive 3 is still a positive 3. Nothing changes. So I have this point. So that point became there. So I have this point right here got shifted up to here. This second point got shifted up there. The green one stayed the same, no shift at all. And now let's check this. I gotta change color on my smart board here, sorry. Let me click over here on this part of the screen. All right, this point. What is the absolute value of -1?
Of -1, you said?
Yeah, what's the absolute value
One.
of -1? +1. So this point's gonna get shifted up to +1. 2, +1. So this point got shifted up because it was a negative turning to a positive. This point got shifted up. And this point, I shouldn't say shifted up, I should say reflected up. The absolute value works like a reflection. So these are our points. These are our new points. So now let me click the graph. What do you think? Did we do it correctly? Does Desmos, let me clear some of this so you can see. Does Desmos seem to agree with us? Is the graph going through those points that we just plotted?
Yes.
Yeah. All those points stayed this. All those points got shifted like that. So notice on the green, do I have anything on the negative side of the graph? Any graph anymore? When I take off that one, is there anything on the negative y's?
No.
No, there's nothing on this side of the graph anymore. I could erase this. That's where the graph was. The negative y's disappeared and they became positive y's. That's how absolute value works. The negatives disappear and they reflect and become positives. Notice these points here that were zeros for the y's did not change. They stayed the same. They're the same on both graphs because 0 doesn't get reflected. So it was only the negatives that disappeared. So that's how you would graph this one, is all the negative y's would become positive y's. So if you were going to go faster through this, you just look at it and say, oh, if I'm taking the absolute value of y's, this part of the graph would disappear. So whenever it starts to go negative, it's just going to get reflected up. And so now this goes away, and this piece just gets reflected up. And so this part goes away. That's basically what happens. The negative y's become positive y's, and this would be the graph where all y values are positive. Now, I added one that wasn't on the bell ringer, but I wanted you to see right here. Now notice this time what I've changed about the absolute value. What do you see with this absolute value here? How's that different from number 3? Here's the absolute value, and this one. Here's the absolute value. What's the difference here?
The absolute value signs are on the X.
That's right. And so
Inside
now,
parentheses.
that's right, that's inside. And according to rule number 1, inside is horizontal, meaning the X value. So it's the absolute value of X. But the rule number 2 right here says that inside lies. So what does that mean? With inside lying, normally on absolute value, what we do is you take all the negatives and turn them positive. That's what should happen. Normally with absolute value, what happens is your negative y's become positive y's. That's just what we just did. But because the rule number 2 says that inside lies, when you take the absolute value of X, here's what happens. All positive y's, not y's, I'm sorry, x's become, let me try spelling again, become negative x's. Why is that? Because rule number 2, inside lies. The x's will lie to you. I've heard it, I tell a joke sometimes if we're in person. I'm going to go ahead and tell it now. I say this: you marry your y's, but you break up with your x's because they were always lying to you. What am I trying to play off words? Inside is X, outside is Y, which sounds like wives. You marry your wives, but you break up with your exes. Why? because your x's were always lying to you. So that's just kind of a little memory device to help you out. Your exes will lie to you, but your wives you marry because they tell you the truth.
Pretty sure we're all gonna remember that.
All right, good, good. All right, so marry well. You won't have to, it'll stick with you. Okay, so here what we're gonna do is we're gonna take all the positive x's and make them become negative x's. So positive x's become negative x's. So when I check out this graph here, and I'll show you the Desmos in a second. Let me just clear that ink off there. So, all right, let's take a look at what's going to happen. So here's the graph on both of them. They're the same. What's going to happen is all your positive x's, so all this side of the graph is going to become the negative side of the graph. So this part is going to disappear. The positive x's, that's this side, here's the x-axis. So here's my positive x's are going to become what?
Negative?
Negative x's. So all this side is going to reflect. So this is going to reflect over and become like this, or wow, that was terrible. Kind of like a sombrero or something. The positive x's are going to reflect and become negative. That's how this graph's going to look. So ultimately, I'm not a very good artist, so I kind of drew it over there. It's going to look like that. That's ultimately what's going to look like. Let's take a picture on, or let's look at Desmos. So here was my graph, and I go down, and it's this problem here. I click it. Notice what happened. It's just like I said, they took the positive x's, and they made the positive x's turn negative. So this positive x of 2 became a negative 2. This point was for the old graph. It's gone. All of the negative side of the graph got erased, and it just was a coincidence that this, so it got erased, but this side filled back in this, and so that's why that part of the graph is still there, is because this side right here got reflected over here. And so that's how the graph looks. So that was absolute value transformations. I wanted to go over that. And so now I have the very end of lesson 1.5. That's right. I know we're 1.6 today, but I brought up the very end of lesson 1.5 just to kind of go over it again. And I just want you to tell me really quickly, would this be outside, meaning it's the absolute value of the y's, or is this inside absolute value of x's? What are we taking the absolute value of on here, example 7a from lesson 1.5? What would that be? Absolute value of x's or absolute value of y's?
Y's?
Y's, very good. That's the absolute value of y's. And do your wives tell you the truth, or do they lie to you?
They tell the truth.
Tell the truth. So that means negative y's become
Positive?
positive y's. And so the way you would do this problem, to take the absolute value of y, is you'd look for any negative y, which here's the negative portion. And instead of this being a negative y value, it becomes a positive y value. And so this graph would just go like this. And this part goes away. That's why the graph looks like that. Or 7b, this time, is that absolute value on the inside or the outside of the parentheses?
The inside?
It's inside. And so the rule is inside's horizontal and inside lies. Or said another way, if it's with the x, it lies to you. Your x's are liars. So the absolute value of x, what that means is positive x's
Or
become
negatives?
negative x's.
Even though they have the absolute value next to them?
That's right, because they're liars. X's are liars. That's why you broke up with them. Got tired of those lies. So I'm going to show you the absolute value of x now. Is I take the positive x's. So I'm looking at the x-axis. The positive x's are going to reflect and become negative x's. So this goes away, and this would just get reflected this way. Wow, that is so ugly. Let me try that again. I'll put a point to help me out. This point got reflected there, and so it would go like this. I still messed up big time. How about I just click this and show you the actual picture here. There it is. Why don't I do it that way? So that's what would happen here. The positive x's became negative x's. And here's one more. If we were going to do this, it was like the DOL for last class. G of x, you'd be finding the absolute value of y's. Do they tell the truth or do they lie?
They
Your
lie.
y's,
Oh,
y's tell you
the
the truth or they lie? They tell you
Oh,
the
they
truth.
tell you.
So that means take your negative y's. So you'd look here, you take any negative y. So I'm looking at the y-axis. The negative portion is this piece. And you reflect it, make it positive. So it looks something like this. So that's G. I'm just going to call it G. You'll learn later. You don't have to write the X part if you're just drawing a graph. That's standard. You can just write G like that. Everybody knows that means G of X. So it's just a shorthand way. That would be the green part, and this would go away. So your graph would look like that. Or for H of X here, I'll go purple. For H of X, you take your positive X's and make them negative. So you're looking now on the positive X's, which is this portion, and this would get reflected this way. And this part would go away, and this part would go away. The negative X's would disappear, and all you would have is the positive becoming negative. That's how your two graphs would look. So if you don't believe me, sorry, I got to take these off. We could type these in. All right, now I got that. I'm going to type in this equation here. It says f of x equals 3 divided by 2x plus 1. And so the first one, if we said g of x equals the absolute value of f of x. Oh, I got two f's. F. 2s. Let me just label this f2. Here we go, and call this f2. So you can see this graph represents what we had here in green, that portion. And then if I changed it to where the absolute value was on the inside, this graph now represents what we had in purple. All right, so that was the review of last lesson. I wanted you to see absolute values and also just wanted to go over those rules. Today's lesson for 1.6 is the most part over composition of functions. And so that's why I want to hit before you start watching the videos, because composition, what that means is you're putting together two or more equations. And so you can watch the videos for example one, and example one I think is more self-explanatory. Where I want to get to is I want to walk through one more time what's called the domain. What we can do is we can put one function inside of the other function. That's called composition. And so it looks like this. What happens is you have one function. Let me give you an example before I do this. Here, new page here. Okay, what happens with composition, and I'm going to make this equations really easy. Let's call this one x plus 7. When you do composition, it looks like this. They have F, O, G, something like that. We'll call it, like, I call it fog a lot of times. And if we're looking for f of g of x, what that means is you're going to have your f equation, but instead of putting in x, you put g inside of it. So it kind of looks like this, mathematical symbols. But another way of explaining it is like this. You take your f equation, which was 2x minus 3, but instead of the x, you replace the x. You replace the x that was here with g's equation. So instead of having f of x, you have f of g. And so g's equation goes in the place of x. Notice where my x was supposed to be, right here, I replaced that with x plus 7. and you would simplify to get your answer. And so I would need to distribute this, and so I'd have like 2x plus 14 minus 3. And so my final answer would be that 2x plus 11 is f of g of x. That's how it works. Now, I'm going to give you a technique in the video that I think works a lot better. It's called stacking. And so with stacking, to get this answer, the easier way is you stack one equation on top of the other. You go in order. So this says f of g, so f gets stacked on top of g. And what I do is I put a parenthesis around the equation, and then I just draw an arrow where it's substituting. So it kind of makes it easier to see. And you say, okay, I'm going to have 2, and then instead of this parenthesis, I replace it with that. 2x plus 7 minus 3. And then I would multiply to solve, and you'll get the same answer that we just did. We're going to end up getting 2x plus 11, as we saw down below. But I think it's easier to see in this form. So I'm going to give you one more here, just to make sure you're following me with a new problem. This time I'll give you 3 equations. So let's say we had f of x equals 2x, g of x equals x minus 1, and h of x is 5x plus 2. If I ask you what is f of g of h, what you would do is you would take this equation here, substitute it in to this x right there. So I'm doing stacking technique. Notice it goes f, g, h. I stack f, g, h. You start from the bottom, you work up. So I substitute this in for this x. So I would have 5x plus 2. That got substituted right there. And then I subtract 1. Well, I can take away the parentheses, because parentheses mean multiply, but there's nothing to multiply with. So I can take that away. And that just equals 5x plus 1. And so then I would substitute it into this equation. So this right here will get substituted in right there. And so I'd have 2 times 5x plus 1. So my answer this time would be 10x plus 2 when I distribute. So f of g of x would be 10x plus 2. Now, just to make sure you're not utterly confused, I'll do one more. And this time, I'm going to say, okay, we have f being, let's make it just x plus 5. I'm just making up random numbers here. G being 3x, h being 2x plus 1. And I want to find f of g of h. And this time I'm going to give you a number. Instead of saying of x, I'll put a 4 here. And so how would you do this? Because you're going to see this. Well, this time I put a 4 in for x. So I actually put a 4 below. And you always write in order, f, g, h, f, g, h. And then if you have a number, that goes below. And I put it directly below this x. So 4 is going to substitute in right here. So I have 2 times 4 plus 1. 2 times 4 is 8. Add 1, I get 9. Then what do you do? Next step is I'm going to take this 9 and plug it in right here. 3 times 9 is what this becomes, which is 27. And then I'm going to take that 27 and substitute it in right there. And so it becomes 27 plus 5, which equals 32. So f of g of h of 4 would be 32. Now I know I went really fast there. You have a lot of videos. I just want to give you an introduction so you can see this extra time. But that's how you would find composition of functions. Now, why did I show you that? Is to tell you one of the things that really confuses some students is after the end, they're going to start asking for the domain. So f of g, if you have to find domain, here's how it works. So remember, f of g is like stacking f on top of g. You would stack in this order, the first letter on top of the second letter. When you do domain, you start with the bottom equation, which in this case is g. You start with the bottom, and you say, okay, what value numbers were in the domain. So here's the starting domain. 1, 2, 3, 4, 5. This is the range. So that's not a part of the domain. This is the domain. You start here. And then you compare it. What you end up doing is you have to see the second equation you write over here, F's. You have to determine what values of the range of G match the domain of F. So I'll say it again. You have to see what range matches the domain of F. So in this particular case, as I'm comparing this one to this one, and I see 6 matches, and I see an 8 matches. So what that means is this: for the total domain of f of g, you track only the ones that match all the way across, where you can draw arrows all the way across. So since these match, I'm going off these 2 pathways. I could get a 6 from here. I could get an 8 from 2 places. So these are the 2 that match. I'm only looking at 6 and 8. I could get an 8 from a 3, and I also got an 8 from 1, which means 1, 2, and 3 are my domain. And then over here, 6 became a 13, and 8 became a 14. Those are my range. So when you have to do domain and range, this is how you look at it. You first write out the bottom equations, domain and range, and then the top equations, domain and range. You match the range of the first to the domain of the second. Whichever numbers match. What I mean by that is 6 matches with 6, 8 matches with 8. There was no 7 over here. There was no 9 over here. So it's only these 2. Then you trace back. The domain becomes this one's domain of the matching values. So 1, 2, 3. These are the matching values, so that became my domain. The pathway led to here. This becomes my range of the f of g. This is f of g here. F of g's domain, that's f of g's range. It's all about that matching. So I want to give you that because that'll really help you on ALEKS. Because on ALEKS, I have a few of these that are testing, and if you just connect your paths like this, you can come up with your numbers. So at this, I'm going to let you ask some questions.